In the event that you put it where the sun is, it would stretch out to the orbit of Jupiter, colossal, entirely unsound, and going to detonate. They are among the greatest blasts of radio energy in the whole universe, producing more energy than a billion suns. Insect Jew, or creepy crawly Jew, is a red Goliath star. In the event that you put it where the sun is, it would reach out to the orbit of Jupiter, gigantic, entirely temperamental, and going to detonate. When we consider stars, we probably envision little glossy things in the evening sky. Essentially, this is how we see them from down here on Earth, yet stars are something totally different. As a matter of fact, one of the greatest stars, Betelgeuse, happens to be much bigger than our sun. For quite a long time, this star has bewildered researchers. But as of late, something more disrupting has been going on with Insect Jew, making researchers and other well-informed people extremely concerned. Go along with us in this video as we investigate the awesome news about Betelgeuse, its looming annihilation, true to form by the James Webb Space Telescope, and how this new advancement will influence our universe and our lives here on Earth, as explained by physicist Michio Kaku. Betelgeuse is a vast miracle, a massive star that has intrigued cosmologists for so long. A Greek stargazer named Antonius was the first to discover it. This star is so colossal that it can be found in the night sky from Earth, especially during winter. If you're into astronomy, you've probably seen or heard about this star. It is the rosy orange star that marks the upper left shoulder of the Orion constellation. So, you see, this star is ancient and, so far, one of the most brilliant stars in the night sky. But one thing about Betelgeuse's brilliance is that it doesn't remain steady. Rather, it fluctuates. This change is one of the exceptional properties of the star, but it isn't the only one. Let's take a look at some of Creepy Crawly Jew's specific properties. Most of the stars you find in the evening sky are a long way from Earth. The closest star is 4.2 light-years away from Earth. On the off chance that you fail to see how the term light-years makes sense of distance, picture it this way. Consider moving at the speed of light for an entire year. It's been demonstrated that light can cover a distance of 186,000 miles per second. Therefore, the distance light can cover in a year is equivalent to 1 light-year. Assuming you do the math, you'll have billions of miles. So, when we say the nearest star is 4.2 light-years away, it means it is billions of miles from Earth. However, think about this. Some stars are significantly farther, and Insect Jew is one of them. Insect Jew is found roughly 600 light-years away from Earth. So, if you somehow happen to travel to it at the speed of light, it would still require 600 years. We can't move that fast, not even our quickest space rockets can. Yet, this star can still shine so brilliantly in our sky. If you're wondering how Betelgeuse can be so brilliant in spite of its distance, that's because of its different characteristics like size and brilliance. Betelgeuse is around 500 times bigger than our Sun. Its radius is accepted to be multiple times that of the Sun. Unfortunately, it appears as a disk in space when using modern telescopes, while different stars appear as little points of light. This appearance is thought to be an effect of the reactions at the outer layers of its atmosphere. With regards to mass, Betelgeuse weighs around 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers. One solar mass is equivalent to 2 times 10 superscript 3 kg. Researchers can't decide the exact mass of Betelgeuse since there are no other planetary bodies orbiting around it to compare it with, and of course we can't measure it directly from here on Earth. But this makes Betelgeuse at least multiple times heavier than our Sun. The brilliance of Betelgeuse goes from magnitude +0 to +1.6. In more recognizable terms, Betelgeuse is multiple times more brilliant than our Sun. No wonder it was nicknamed a red Goliath. Anyway, the brilliance of Betelgeuse doesn't remain steady. It fluctuates. This fluctuation is due to its throbs, or in other words, creepy crawly Jew expands and contracts. When it grows, it gets more brilliant. When it contracts, it dims. This cycle can last for 10 to 100 days or even much longer. A unique property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field in these areas is far stronger than at the normal surface. However, the downside is that these strong magnetic spots hinder the flow of hot gas to the star's outer surface, making the star cooler in these areas. The fact that Betelgeuse has so many of these spots compared to our Sun explains why it is cooler than our Sun. despite its size and brilliance. The Sun also has its own dark magnetic spots, but those on Betelgeuse are much larger and much more numerous. To give you an idea, the spots on Betelgeuse can be twice as large as Earth. Betelgeuse also boasts a magnetic field that is multiple times stronger than that of the Sun. This field is the reason that when viewed through a telescope, the gases on the surface of Betelgeuse appear to be in loops or arcs. Betelgeuse has a surface temperature of around 3,500 Kelvin. This low temperature contributes to the low energy emitted by the star and its faint red color. Betelgeuse is a red star, but it wasn't always red. It was yellowish about 10 million years ago, like our Sun. Over time, the color began changing to orange-red, and then around 1 million years ago, it gradually started turning into the red star we know today. This fact has led researchers to believe that the star is aging. Betelgeuse emits as much as multiple times more energy than the Sun. It would have been a fierce competitor to Earth's Sun if it weren't so far away. The fact that Betelgeuse, which is 600 light-years away, can still be seen and identified with the naked eye at night is very striking. Our Sun is only 8.3 light-minutes away from Earth. That's why it's so powerful. If Betelgeuse were just slightly closer, we would also be able to see it during the daytime. But if it were to replace the Sun, it would consume or displace the Earth and the other 4 planets near it because of its immense size. Moreover, even if it were to match the Sun in size, it would still emit more radiation. Betelgeuse, also known as Insect Jew, is a very Goliath star located in the constellation Orion, roughly 600 light-years from Earth. Its monstrous size is one of its most striking features. It is multiple times bigger than our Sun in terms of radius and could easily encompass the orbit of Jupiter if placed at the center of our solar system. This epic size allows Betelgeuse to appear as a disk rather than a point of light when seen through powerful telescopes. In contrast to most other stars, despite its colossal size, Betelgeuse is not the most gigantic star. Its mass ranges from around 12 to 19 times that of the Sun. This variation in mass estimates is due to the difficulties in accurately measuring the mass of stars that lack companion stars or other objects to provide gravitational reference points. Even at its lower estimated mass, Betelgeuse remains a significant celestial body. The brilliance of Betelgeuse is another key characteristic. It fluctuates regularly over time, with its brightness ranging from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times more brilliant than a magnitude plus 1 star. At its brightest, Betelgeuse can be up to 1,000 times more brilliant than our Sun. This variability is attributed to its throbs, periodic expansions and contractions caused by internal processes within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it darkens. These throbs can last for days to months, contributing to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a massive star, measuring around 3,500 Kelvin. This gives it a distinct red hue, typical of red giant stars approaching the end of their life cycle. Like other red giants, Betelgeuse is in the late stages of stellar evolution. It has exhausted the hydrogen fuel in its core and has begun fusing heavier elements. This fusion process generates energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena. It exhibits dark magnetic spots on its surface. Where the magnetic field is stronger than the surrounding areas, these spots prevent the convection of heat, leading to cooler regions on the surface. Despite these cooler spots, Betelgeuse remains a massive, energetic star, though it will eventually meet its end in a spectacular supernova. Betelgeuse is a massive star nearing the end of its life, and its eventual fate will be a dramatic one. When it runs out of fuel, it will go through an intense process of fusion, turning heavier elements like helium and carbon. This will cause the star to expand to even greater sizes, likely making it one of the largest stars in the night sky before it dies in a supernova. A cataclysmic explosion that marks the death of a massive star. The force of this explosion will be so intense that it could have profound consequences on nearby planets, including our own. However, it will likely be many thousands of years before Betelgeuse reaches the end of its life. This distant, powerful star will continue to intrigue astronomers for generations to come.